Hi, this is a part of our assignment. So here, as a part of problem, there's a large CPG business which wanted to know which products would be sold in the stores to maintain their right inventory and avoid out of stock scenarios. This will help also improving the business in two folds. One through repeat purchases, and secondly through getting the cross-sell recommendations. Um, as a part of the task, so that we translated this particular business problem to a machine learning classification based model and framed it as a problem whether which predict whether a product will sell in a retail store next month or not. So with 300 products and 500,000 stores data, we were generating about 15 to 20 million recommendations each month. Um, so um, from the task perspective, we determined the internal and external data sets. We got the data, we stored it in the data in a Azure environment, prepared and transformed the data, and created the derived variables or the KPIs to create the feature sets. And then finally, as an outcome, we created an analytical data set in a HDFS and the Spark and Azure environments. We performed exploratory data analysis, did correlations, descriptive statistics, looked at the trends and seasonality and so on. We also built and evaluated various classification algorithms, logistic regression, random forest, ensemble models, to some extent the neural networks as well. And we evaluated each one of these models on the key metrics like precision, recall, offense score. And then from the insights perspective, we presented on business and the model outcome and insights, as well as the on a every month we presented the performance insights with the key metrics on sales per store, unique SKUs sold per store, the adherence and recall metrics on a various cuts, like a category at a region level, at a store level, at a category brand SKU level. Um, so all these insights and the root cause analysis were presented through Power BI and through executive presentations. Then we explained, we from a user's experience design perspective, these recommendations were presented on a salesman handheld device eventually, and then we clicked the performance of the data, how the salesmen have sold in the store and so on, and then created a performance reports on a monthly performance reports on a Power BI, and executive presentations were eventually shown it to the leadership team. Then from the user experience input and the feedbacks perspective, we salesmen's inputs were considered on the recommendations, and the model adjustments were made accordingly. So, like for example, certain products were not recommended on a promotion, but we eventually find it out that these products were not given as a part of our input in our data, and we kind of classified them. So we henceforth asked them to kind give this particular data every time, but they kind of put this data in a database so that we can extract the history of the data and so on. Then, from adherence and recall metrics were presented every month on a performance for the recommendation engine. The reason for low adherence was analyzed and presented, and improved presented to improve the processes for business and the data inputs. From a privacy standpoint, we ensure there's a data masking on a consumer PII data. We also ensure there's no data leak outside the client's environment by restricting any data downloads outside the team working environment. Then from our ethical considerations, we removed unwanted features which are not significant based on the model. Hence, there's no bias on those feature sets that we need to increase, and there's an overfitting or underfitting kind of scenarios were kind of removed. Then we experimented on various models, not just stick to the the model which a team is quite well aware of, or they know that this model will do well. So we hence experimented on logistic regression and forest ensemble models, and we then compared which model is the best based on the adherence recall and offense score, but also we ensure there's a from a business outcomes standpoint when we do a train and test and validation data sets, we also compare that from this test and the validation data sets. What are the outcomes from the hit rate or adherence piece and a recall rate, and accordingly we pick and choose the model. So there are two approaches we take it, not just from a model but from a business point, to pick up which is a right model, which is a right algorithm to be picked up. From a historical period consideration, we experimented on 6 months and 12 months data, so that there's no bias on the training periods and testing period and so on. Then from the fairness standpoint, the train and the test and the validated data sets were built on the models, and the models were experimented. Since we were accountable, we also provided transparency on the key model outcomes, like summarizing results from the various models, translate them to the business problem identification. This helped to improve the data quality and the processes, which in turn help improving the model results, which is in turn the implements implicit and the explicit feedback loop mechanism. Thank you so much.